Pluto, a distant and enigmatic celestial body, once belonged to our solar system's planetary family. However, recent, alarming statements from well-known astrophysicists like Neil deGrasse Tyson and Michio Kaku have thrust Pluto back into public attention. They have made a startling revelation. Pluto might be on a potential collision course with Neptune. However, how could such an incident occur? And what would the consequences be? Is this an unusual cosmic event? Or is there something more to this imminent cosmic influence? To us as we investigate the possibilities of Pluto becoming a collision course with Neptune. Pluto was once classified as a planet, but it was later renamed as a dwarf planet due to its peculiar orbit, which continues to captivate the scientific community. As revealed by recent research by well-known scientists, Pluto's course is dangerously close to the orbit of Neptune. Renowned astrophysicists like Tyson and Kaku are raising alarms about the possibility of a devastating collision between these two celestial bodies, a scenario that might be a serious threat to Earth. But how could such an occurrence happen? Unlike any other planet in our solar system, Pluto's journey around the Sun takes a very unusual form. A remarkable 248 years to complete just one orbit. To its discovery in 1930, Pluto has only completed one full orbit, which adds to its mystique. But Pluto's orbit is not just slow, it's also highly elliptical, vastly different from the more circular orbits of the larger planets. To complicate things further, the orbit of Pluto is skewed at an angle of 17 degrees. This inclination makes its path much more extreme than the other planets, introducing new levels of complexity to its movement. One of the most intriguing features of Pluto's orbit is its interaction with the orbit of Neptune. For roughly 20 years of each orbit, Pluto comes closer to the Sun than Neptune does, defying what we might expect based on the planet's relative positions in our solar system. This naturally raises the question, why hasn't Pluto collided with Neptune? The solution lies in Neptune's gravitational influences and those of other celestial bodies, especially the large planets. The study of Pluto's orbit began shortly after its discovery. Astronomers were puzzled by its strange path. Other planets whose orbits are somewhat aligned with the ecliptic plane, Pluto's orbit stood out due to its steep tilt and elliptical nature. The realization that Pluto's orbit crosses Neptune's was a major point of scientific curiosity. Despite these irregularities, the stability of Pluto's orbit is a remarkable feature of space mechanics. The phenomenon known as the three-body problem comes into play when studying the movements of Pluto, Neptune, and the Sun. This problem involves comprehending the manner in which three objects move and affect each other through the prediction of gravitational forces. Their paths are a complex task, and this is where terms like AML vibration, scope vibration, and VZK wobbling become relevant. The concept of AML vibration refers to the fact that when Pluto crosses Neptune's orbit, it remains at least 90 degrees away from Neptune, ensuring their paths do not intersect. Vibration describes the vertical movement of a celestial body in its orbit. For Pluto, this means that when it approaches Neptune or any other large planet, it is positioned above the plane of their orbits, offering extra protection against possible collisions. The VZK wobbling, named after the researchers VZ and K, who studied how space objects interact through gravitational forces, explains how Pluto and the Sun's gravitational pull on Neptune influence each other, keeping Pluto's path stable despite its apparent erratic behavior. Even though Pluto's orbit may appear erratic, its wobbling mechanism aids in its steady motion over long time scales. These complex forces help ensure Pluto's orbit remains stable, preventing it from crashing into Neptune or deviating wildly. The three-body problem is essential for understanding how orbits change due to the gravitational influence of multiple objects. Studying this helps us gain a deeper understanding of Pluto, our solar system, and even distant celestial bodies and the orbit of Pluto. Current models suggest that a collision with Neptune is highly unlikely in the near future, remains unpredictable due to the nature of celestial dynamics. Can never completely eliminate this possibility. Gravitational interactions with other celestial bodies will continue to shape Pluto's trajectory. Even the gradual transformation of the Sun from a white star to a red giant and its eventual collapse into a white dwarf could alter the solar landscape, subjecting the gravity system to changes that could impact Pluto's orbit. But the probability of Pluto colliding with Neptune anytime soon seems remote. The inherent uncertainty in predicting the dynamics of the universe over vast time scales means that anything is possible. The forces at play in orbital mechanics are powerful and intricate, and even the slightest change can accumulate over billions of years, potentially leading to major shifts in the orbits of distant objects. This uncertainty in space exploration brings us back to a core principle. The more we learn about the cosmos, the more we comprehend how much remains unknown. The study of Pluto and other distant objects in our solar system continues to challenge our understanding of planetary orbits, gravitational interactions, and the fundamental laws that govern the cosmos. As scientists continue to observe Pluto and Neptune, new data may either challenge or bolster our current theories. Whereas the concept of a catastrophic encounter between Pluto and Neptune may appear remote, it serves as a reminder of the mysteries that space still holds. As our tools for space exploration advance, providing us with more accurate ways to simulate, predict, and observe these cosmic phenomena, the potential for a collision or near-miss between Pluto and Neptune remains a compelling example of the complexity and unpredictability of our solar system. Whether such an event will ever take place is unknown, but it highlights the ever-changing nature of our cosmic environment. The story of Pluto's orbit invites us to think beyond what we currently know and to embrace the mystery of space. It challenges us to look at the universe with fresh perspectives and to continue being open to surprises that lie ahead. As scientists continue to unravel the mysteries of the cosmos, we are reminded that we have only scratched the surface of what the universe has in store. Whether Pluto and Neptune will continue to orbit safely or one day experience a cosmic collision remains an unanswered question that only time and further discoveries will answer. As we move forward in our understanding of the cosmos, the story of Pluto's orbit serves as a representation of the mysteries that continue to confuse and thrill science. The potential for a collision or the proximity of Pluto and Neptune, even though it is unlikely to occur anytime soon, is a reminder of how much more we need to learn about the vastness of space. These celestial events, no matter how improbable they may seem, invite us to keep asking questions about the fundamental forces of the universe at play in the ever-expanding field of astrophysics. There is always more to discover as we delve deeper into space exploration. The tools and methods used to study distant worlds like Pluto are advancing. High-tech telescopes, space missions, and more advanced computer simulations allow researchers to track these celestial objects with unparalleled precision. These innovations provide new insights into the mechanics of planetary gravitational interactions and the long-term stability of our solar system. One of the most exciting developments in the study of Pluto and its orbit is the advancement of observational technologies. New space missions are constantly being launched with the goal of exploring distant objects in the solar system. These missions, such as the New Horizons probe, have provided important information about Pluto and other objects in the Kuiper Belt, offering a closer look at the characteristics of these far-off worlds. With each new discovery, our understanding of these distant bodies becomes clearer and we gain more insight into the processes that regulate their movement. The fact that Pluto remains an object of intrigue and study, even after its reclassification. The dwarf planet speaks to the ongoing fascination with this far-off world. Pluto may no longer hold the title of planet in the eyes of the scientific community, but it still occupies a significant place in the public mind. Its reclassification has sparked debates about the definition of a planet, the complexities of our solar system, and the ways in which our understanding of space is continually evolving. The ongoing exploration of Pluto's path reminds us of the fluid nature of scientific knowledge. What we understand today may change tomorrow as new data emerges and new theories are proposed. The potential for a future collision between Pluto and Neptune is a possibility that cannot be dismissed completely, but it also reflects a broader theme of unpredictability in the very nature of the universe is such that we can only predict with a certain level of confidence, and even the most carefully crafted models can be appended by new findings. The pursuit of knowledge in astrophysics is driven by the need to learn the fundamental workings of the universe. By studying Pluto and its relationship with Neptune, scientists are not only examining the specific dynamics of these two celestial bodies, but also gaining a deeper understanding of how gravitational forces shape the motion of all celestial bodies. The insights gleaned from these studies have far-reaching implications, not just for our solar system but for the broader understanding of planetary systems across the galaxy. The study of Pluto's orbit also highlights the importance of collaboration within the scientific community. Astrophysicists, astronomers, physicists, and mathematicians all contribute their expertise to the analysis of Pluto's movement, each presenting a novel perspective on the problem. Collaboration has led to the development of more refined models of planetary motion and a better understanding of the delicate balance that keeps the solar system in harmony. Even though Pluto's potential collision with Neptune may seem like a far-off possibility, serves as an important reminder of the ongoing challenges we face when making predictions regarding distant objects in the universe. The chaotic nature of celestial orbits means that anything can happen, and our understanding of the universe will continue to evolve as we gather more data.